Welcome to clickmyproject.com. Let's see about improved design of frequency response masking filters using bandage shaping filter with non-periodical frequency response. Discussing about the paper, it is clear that the process of designing a filter needs a certain set of requirements. Later, it is analyzed that it is approximately an optimization problem. So, the difference between the desired filter and the designed filter should be minimized. The main aim of the designing of these filters is to reduce the complexity. So, the drawback of FAR filter is overcome by frequency response masking technique. In this technique, first of all, the filter is interpolated to get the transition band. Then the interpolated filter and the complement are masked. Finally, the result is obtained by combining all these together. This leads to low arithmetic complexity. This is the flow diagram of frequency response masking technique. The first block indicates the complexity reduction using two-stage FRM. The complexity is nothing but the amount of computations required in a system should be few. It is mainly presented in finite impulse response filter framework. The main idea of this is to expand the design space. In the proposed approach, the masking filter decouples the bandage shaping filter. With the introduction of additional decoupling stage, complexity of overall filter can be reduced greatly. So next, the determination of passband and stopband edges. The edge detection is essentially finding high intensity gradient. In the presence of noise, we need to suppress high frequency intensity. For masking filters, stopband and passband edges are to be determined. That is, the band edges of subfilter are to be determined. Next, considering the determination of the interpolation factors. Interpolation is the process of upsampling followed by filtering. Goal is to find particular set of parameters which leads to a design with low complexity. The primary reason to interpolate is simply to increase sampling rate at output of one system so that another system operating at higher sampling rate can input the signal. Interpolation factor is simply the ratio of output rate to input rate. Through this, we can minimize the number of multipliers used in the system. The next thing is ripple function analysis. Ripple function analysis is considered to be carried out in three cases. The zero phase frequency response is determined. Then the ripple is analyzed based on different regions. Finally, the ripple of overall filter is determined by maximizing the value of ripple of masking filters. The next thing is summing up of all the transfer function. This is nothing but there are initially two switches. Input signal is passed through two filters with transfer function. Then subtract the output of two subfilters and store it in separate latches. That is, the output of one is kept in T1 and the other is kept in T2. The signal in two latches are passed through filter with transfer function. This is added altogether to get the final output signal. This is a MATLAB command window that consists of a FRM coding, and these are the subfunctions which holds the main, and these two are the audio files which is inserted in the coding to be processed. And now let me run the main function. Now we have to click the run file option to make our program to be processed. It takes few minutes to be executed. So initially we have to provide our input to get the output. That is, it will be asking the passband ripple and the stopband ripple. So for the stopband ripple, I am giving 3. Then it will ask for the passband frequency and the stopband frequency. Later, it will ask for the sampling frequency, which is used mainly in the concept of interpolation. So after giving our input, the corresponding output graphs will be displayed. It will take few minutes to be loading. The process is going on, that is mainly based on our filtering process. So in order to reduce complexity, we do the following things. By giving these inputs, we will be analyzing our interpolated signals from the original signal, and further we will be analyzing our ripples. So let me explain the graphs and its output. So initially the figure 1 was displayed as a constant thing. This is the figure 1. Initially it will be like as a constant thing, and later in figure 2 we will be calculating our delay, and in figure 3 we will be calculating our ripple analysis, which is followed by in figure 4, and in figure 5 we will be calculating our interpolation signal, that is the variation between the original signal and our interpolated signal. Then in the figure 6 we will be getting our magnitude versus frequency response graph, which is plotted as per our procedure. So as per our results, we can conclude that the complexity design for sharp FEM filters has been reduced, and the usage of multipliers were also low, and it is implemented in a banded shaping filter with non-periodical frequency response. When compared to the previous FRM schemes, it is more significant in savings. Thank you.